Thank you, Dr. Hiba, for your leadership and dedication. Before we continue, I'd like to make a few housekeeping announcements. Firstly, please be aware that today's sessions will be recorded for educational purposes. Additionally, photographers will be present to capture the moments throughout the event, so remember to smile. Please don't hesitate to ask questions. There will be a dedicated time period at the end of each session for Q&A. For the panel presentations, we have QR codes flashing up on the screen behind me for you to ask your questions. Simply scan the QR code at the start of the session and type your questions as instructed. Our team will moderate them and forward them to the speaker during the Q&A period. If you prefer the traditional way, we have microphones set up in either aisle where you can line up and ask the questions yourself. Feel free to approach the speakers during the break as well to ask any questions. A gentle reminder to please return to the sessions on time after breaks so we can make the most of the day and stay on schedule. Lastly, if you have any questions or need assistance during the event, please feel free to approach any member of the Applied Experiential Learning team. We now move on to our morning session that features an exciting and thought-provoking panel discussion titled Innovations in Education and Research, Bridging Technology and Academic Advancement. This session brings together some of the brightest minds in educational technology, offering valuable insights into how technology is transforming education and advancing academic excellence. Joining us today, we have the following esteemed panelists. Mr. John Bicknell, co-founder of Tutello UK. John has over 30 years of experience developing educational software for both the public and private sectors. His work focuses on personalized learning and using AI to improve student outcomes. We had the pleasure of working closely with John while piloting Tutello, our intelligent tutoring system here at UDST. Dr. Natasa Milic-Frayling, Research Director at the Qatar Computing Research Institute. Dr. Natasa leads the Arabic Technology Group. With over 25 years of experience in computer science, she specializes in knowledge systems focusing on privacy and transparency of systems design. She is also the founder of Intact Digital Limited. Dr. Vincent Widmer, co-founder of Beekee, an edtech company that focuses on bridging digital learning to low-resource environments. With a PhD in educational technologies, Vincent is passionate about using technology to make learning more accessible to all. We are also pleased to have Mr. Wayne Chisholm as our moderator for today's session. Mr. Wayne has been teaching at UDST since 2005 and brings a wealth of international experience, having worked in Canada, Thailand, and Qatar. With a background in applied linguistics and TEFL, Mr. Wayne is skilled at integrating technology into education. I would now like to invite all of our panelists and Mr. Wayne, please join us on the stage. Please remember, you can submit your questions for the panel using the QR code. We will have dedicated time for a Q&A at the end of the session. Mr. Wayne and panelists, the floor is yours.
Thank you, Randa, for that introduction. Good morning, colleagues, and welcome to our panel discussion, Innovating Education and Research, Bridging Technology and Academic Advancement. Today, we are joined by an esteemed panel, which includes two EdTech specialists or providers and a research expert, who all play an important role in shaping the future of higher education. Our conversation today will focus on three key areas. First, we'll look at emerging trends and institutional needs in educational technology and research. Secondly, we will look at collaboration and practical impact, how partnerships between universities, industries, and research bodies drive innovation. And finally, we'll look towards the future. We'll look at what's next for education and research, and we'll look at how we can stay ahead. So to begin, let's explore the trends shaping educational technology and research, and look at how they align with national goals and institutional priorities. So our first question today in this panel discussion is for both John and for Dr. Vincent. What are some of the most in-demand technologies or solutions requested by higher education institutions today, and how are they evolving to meet future needs?
Good morning, everyone. So for me, there's two key ones. One is around analytics. So with all these digital technologies where a student's sometimes learning apart from the educator, we're gathering data about what the student's doing, but it's rare that it gets passed back in a way that can give information to the educator to take action, to understand how the student's been studying, what they've been doing, to then reinforce the one-to-one, face-to-face learning that they have in the classroom. So there's still a huge gap between data collected and actually creating useful analysis that the educator can use in the classroom. And then the second one, obviously, will be AI. It's a wave that's broken on everyone. Everyone is struggling in some ways to understand how to use it, where to use it, if to use it. And there's a huge demand, really, at this point, just to try and understand where AI might fit in education, knowing that it will, but trying to understand where.
Of course. And Dr. Vincent.
Yes, thank you. Good morning, everyone. So yes, I definitely think that AI will be and is transformative in the education sector. We at Beekee, we have an instructional design team, and we definitely change the way we work doing instructional design. And of course, we use AI to generate quizzes, supporting images, case studies, accessible content. We can easily translate the content, we can generate voice, you can generate a ton of things. And we also use it to generate instructional videos, which is very difficult, very time consuming. So right now, I think that you know that, but you can use like AI avatars to easily generate an AI of yourself and then generate tons of videos in different languages. So I definitely think that AI will be and is a game changer. At the same time, we are all talking about these high-tech and AI things, and I don't think we really are talking about all the learners that don't have access to basic infrastructure. And most of these educational technology tools like AI, but say most of them are cloud-based. And we know that today 3.6 billion of people remain offline worldwide. And most of these people are based in low-resource countries, in developing countries, and they have like a huge youth population eager to learn. And especially in higher education, millions of learners are left behind with these online-only solutions. And I think that bridging this gap is like a moral imperative and also a huge opportunity to innovate. And at Beekee, that's why we provide what we call offline-first solution, offline-first approach. So we developed this product, which is the Beekee box. And the idea of the Beekee box is that it's an offline digital classroom. So our clients, what they can do, sorry, if you can just maybe move to the next slide, because I think there is a picture for those who cannot see the, right, let's go ahead. And the idea of this box is that the trainers can put their e-learning courses on the box and then take the box to the field where the infrastructure is poor quality, and then they just have to push that button. It will generate a local wireless network allowing people in the room to access e-learning content, like if they were connected to an actual e-learning platform, but without internet. All the content is stored in the box. It also has a battery, so it bypasses power cuts, etc. So that's what we do at Beekee. And I think that this approach is really crucial for inclusion, and also we need to ensure that tools aren't only just for well-connected campuses in the world. And I think that emerging tools should not be only evaluated by how they are advanced, but also how they are accessible.
There's the slide is up there now. Thank you. The picture of the Beekee box.
Excellent. So on the left you can see the Beekee box with Doctors Without Borders, MSF, and on the right is in Afghanistan with the ICRC.
Great. Thank you. Thank you. So it's no surprise that AI was going to play a big part in the future of education and technology. Thank you for the response to that question. The second question is for you, Dr. Natasa. From your perspective, what are the current priority areas for research in computing and educational technologies, and how do these align with the Qatar National Vision 2030?
Thank you. I'm really pleased to be here. Qatar is focused on transforming this economy towards a knowledge economy, which means that education is absolutely critical. You can't have a knowledge economy without talent, without knowledge, and therefore both education and research are critical. Now, in my experience, I have worked in different environments. Research in startup is very different from research in Microsoft Research, where I spent about 17 years, or University of Nottingham 5 years. So research plays a different role in different contexts. Putting together education and research is a tricky thing, but actually very, very important. Research is in education part of students' work, because whenever we want something more aspirational, it helps students to do research. So research is fundamentally part of the education already. The question most of the time is for the management: how do you bring research as what I call business? Research, when research becomes a source of excellence to support research, fundamental research, often people shift towards getting grants to be able to do research. And then there is a fine balance between teaching and research. Therefore, that needs to be very, very carefully done. From institute where I'm working right now, Qatar Computing Research Institute, I can talk about the priorities and how we decide what to work on. Because in university settings, normally research goes up to, I would say, a pilot of some kind of innovation. It could be technical innovation or it could be a method. So it could be new nursing method. And it could be piloted, but most of the time stays at the level of a paper and a pilot. And probably that's fine for university level. But if you're working for an institute where you do not teach, then the question is, how far do you go when it comes to making an impact? You can't just say, well, I have done my paper, I have done my demo, this is it. If there's no impact further. And for that type of research, however applied it might be, there's a long journey between the innovation that happens in the lab and then impact is realized by commercialization and deployment. So at Qatar Computing Research Institute, we pick to work on challenging things. This is the most important thing. If you work on challenging things, you may not even solve the challenging thing, but along the way, you will solve many, many other problems. And so working on challenging is one thing. And then picking domains, because we are part of Qatar, we're thinking about what would make the country stronger. So especially in the digital age, when digital is adopted everywhere, cybersecurity is critical. It's critical for the digital sovereignty of the country. The second thing was large language models arrived, AI arrived. So what do? We create large language model for Qatar. And it's very important because it's not just for Qatar to have it, it is to encourage their education, because if you have large language models that can help teachers to create a material that's more appropriate for the culture of Qatar, that's very important. So essentially what we do is pick challenging problems in the areas that matter to Qatar. And then the hardest bit is how do we move from innovation to commercialization? It is impossible to do everything within the institute. So it's a very clever way of creating partnerships with others who can take it out. So normally we do pilots, we create a demonstration system, and then we need to think about productization. Well, who is the engineering team doing it? And that's not even enough, because there is a difference between creating a product and selling a product. And that's why one has to have partners. So overall, the most important thing is challenging problems, get areas that really matter to Qatar, and then do the partnership. Thank you.
Thank you for that, Dr. Natasa. So the next question is for our two EdTech providers, for Dr. Vincent and John. Could you please share a success story where your technology significantly advanced student learning? Dr. Vincent?
Should I start? Yes.
Sure. Yeah.
So yes, we work with Arizona State University, ASU. They have a program called Education for Humanity, and they provide higher education courses to displaced or marginalized communities. And they work in 20 countries. They have more than 20,000 learners across the globe. And they provide English learning courses, entrepreneurship courses, academic skills courses. But the problem is that their learners face with huge barriers. So they have like unstable internet access, high data costs, long commute to the learning center, power outages, etc. So thanks to our solution, ASU can deploy like small pop-up campuses almost everywhere, and it allows their courses to be always available, no matter the infrastructure. And they did a very interesting field study with the Norwegian Refugee Council. So we were not directly involved in this study, which is, I think, very important for unfortunately. And they did it in Lebanon with 11 learners from Syria, Palestine, and Lebanon. These learners had minimal prior exposure to digital learning, and because internet in this region is very, very spotty, our technology was very well received among the learners. And out of the 11 learners, 8 successfully passed the courses, 2 failed, and 1 dropped out. And 60% of these learners found the solution very user-friendly, and 40 of them user-friendly. So overall, very good for us. And what is also very interesting is that the marked improvements in the learner confidence. So I mean, before Beekee, 45% said that they were very motivated to learn. And after the pilots, it goes up to 70%, which is very good. And we understand that giving access to a resilient tool as our tool, and also to a user-friendly tools, can really seems to have a very interesting effect on the learner's motivation, which is, I mean, pretty obvious, but I think that it's very important also to have like real measure of these improvements. And we had similar results with Doctors Without Borders and also the German cooperation. So even if it needs, of course, to be validated with more studies, it suggests that bringing content offline can really have a great effect on the motivation of the learners.
Great. Okay, thank you for that. John?
I'd like to kind of relate a theme of projects that I've done over the years that have had the most success. And it's based around how there's often fear involved in education, a fear of making a mistake. And by creating systems that help to provide ways to experiment and take away that fear, often creates the greatest success. So one early project in the UK, you probably know we don't have the best of weather, and that translates into a very dangerous coastline. And the service that looks after and rescues people in trouble around the coastline is a charity in the UK that's been around for hundreds of years. And they have a network of about 600 very specialised craft to perform rescues in bad weather. They're very technical, and they're all manned by volunteer crew. And I was invited to the charity because they had a big problem with lots of boats being out of service because of technical faults. that were inadvertently caused by the crew trying to fix problems on the boats. And talking to the crew, it came down to like a fear of breaking the boat or doing something wrong. And they often made a clumsy attempt and got it wrong anyway and broke something expensive. So I created a simulation that allowed them to experiment with testing circuits, replacing components, so they could experiment without fear of electrocuting themselves, for one, most importantly, and two, could see what would blow something up. And so they had a chance to try again and again and again until they felt confident with the system. And once we moved that training out across the fleet, we reduced the vessels out of service by a huge amount, by like 90%. Another example was in Imperial College in London for their one of their foundation courses for business, which was in probability and statistics. And there are a few concepts particularly in probability, that aren't natural. You think they should be one way, but really it's something else altogether. And students were struggling to wrap their hands around these ideas. And so again, I created simulations for people to experiment to gradually soak up the ideas rather than trying to kind of battle against them. That turned out to be successful too. And then moving forward to the current project with AI, what excites me most about it is the infinite possibility of experimentation. So the student can keep asking and asking without fear of looking stupid in front of peers in the classroom, and can build their knowledge and build their confidence in this kind of infinite resource. So this is the kind of pattern I'd like to continue.
Okay, good. Thank you. So the story about increasing the motivation of learners on one side, and how practice, I guess, can help to improve confidence, I guess, in learners. Excellent. Good. Thank you. So we'll move on to the next section in our discussion today. Now that we've discussed the emerging trends, let's turn our attention to collaboration between research institutes, industry, and higher education, and look at how it can lead to meaningful innovation. First question, again for John and for Dr. Vincent. What have you found to be the key factors in successful collaborations with universities? And how do these partnerships typically evolve?
So I'd say without doubt the key factor in a successful software development project is closing the gap between the developers and the end users of the project. In any large project there's always many important roles of project management, overview, designers. There's many layers that are important for the project to succeed, but sometimes those layers get in the way. They become a curtain between the developer and the end user. So the most success we've had is where we can get a developer sat next to the actual person who's going to be using the software and have a conversation with them, where the user can directly relate their frustrations or problems or needs to the developer, and often the developer having the closeness to the technology can instantly pick a solution. So getting that gap really tight is what makes a successful project.
Okay, thank you. Dr. Vincent.
Yes, sorry. So we have a very successful collaboration with Arizona State University, and we really co-developed our solution with them from the very beginning, and thanks to their feedback. And what I would say is that what is very important, I think, is that you have like a shared vision and like alignment. I mean, like having both clear, shared, mutually goals together, which is very important, I think, and also the co-creation of the solution. So best results happen if the two institutions work together to co-create the product. I think this is really interesting for a university, for example. Faculty can contribute with their pedagogical expertise, for example, and technology provider handle the product design and development. And that's exactly what we did with, and what we continue to do with ASU. We really help them to deploy their own pedagogical approach. This is something very important. And also, I would say the ongoing support, of course, very important. I mean, the technology is not, alone is not enough, of course. And we need to give them resources, we need to give them trainings. So for ASU, we train ASU to use our solution, to empower them to use our solution, and they also train their staff and the learners themselves. Something very important also is the iterative approach. They need, I mean, for us, what is important is that our partner needs to be open to pilot programs like feedback loops, iteration, refinement, etc. As a startup, we are agile. That's how we work. So it is something very important, very interesting also for them to work with a startup that is agile like this. It's also a matter of communication. So during the implementation of the project, we have like weekly meetings, and still now we have bi-weekly meetings. So we really need to communicate with them. And yes, that's how we work with Arizona State University. And yesterday I talked with Professor Breda Medra from the UDST and about a potential collaboration on a project submitted to the Educational Laws Foundation. So hopefully we'll collaborate with the UDST soon. So I'm very excited.
Good. That does sound exciting, actually. Yeah. And so it sounds like, again, partnerships. Very important in what you're saying, and going back to what Dr. Natasha was saying as well, about partnerships being really important. Great. Okay, and Dr. Natasha, the next question is for you. Based on your experience at QCRI, how can faculty or academic institutions engage more effectively in industry-partnered research initiatives, and what makes these collaborations mutually beneficial?
Well, there are two aspects here. There is a collaboration among universities and institutes, so people who are researchers collaborate among themselves. And then there is collaboration with industry. And it's very, very different. Why is it different? Because in essence, if you look at any innovation that happens in extraction, you can track it back in some research papers 20, 30 years back, which means that the universities have an extremely important role to play. They have to be able to do what we call fundamental research. They have to be able to keep a distance from the marketplace. And why would industry come to university? They come to university because they don't have money for research. They don't have time for research. Market is moving very fast. They have to feed their people. They have to get revenue. So even organizations like Microsoft has Microsoft Research, but it's not something given, taken for granted. Research can go anytime. So large organizations, or medium, especially small businesses, they cannot afford research. So they come to university, they come to you because they like you to get on board with them, to innovate, close to market, so that they can fit the needs of the customers and they can get revenue and they'll be essentially economically sustainable. How would we then fit this into education? It's very good if you have master's students or undergraduate students who will be really willing to do user studies or contribute some of the algorithms, speed up. So that's a very good way to collaborate with industry because it's a win-win. The education part, the students get to learn about real-world problems, and most importantly for researchers, we get real-world data that we can use if you're doing anything in analytics and need to inform the design. And that we don't have that at universities. So real-world data is great. So the partnership between the universities and industry is a very fine line. If one is really working on innovative research, that means that the market is not ready. So that's the test. If everything in commercial is right away, probably you're too close to market and somebody else can do it. It's not really so impactful unless you're counting, say, revenue as an impact. When it comes to collaboration among universities and institutes, I would just say each organization should stick with their core. So, for example, at QCRI, we are computing. It's focused on computer science and innovation in computer science and digital technologies. But we do not have knowledge in nursing or health. So if you would like to get technology then applied somewhere, we need to team up. So the best thing among the universities is sit down together and say, I'm covering this is my strength. and then we do interdisciplinary research, because that's how we build solutions. The worst thing that we do in computing is we have technology and we try to find a home for it. If you are innovating at the technology level, I would just tell the managers, be patient, because one single technology cannot solve any problem. Normally people have to have a portfolio of things and accumulate, and then somebody will be clever and put it together as a solution. So in short, I would say for relationship with industry, be very careful you don't become the development shop, but take advantage of real scenarios and data if you need it. And then collaboration among institutions, research institutions is all about interdisciplinary research and making sure that we have complementary skills. Thank you.
Great. Thank you, Dr. Natasa. So again, it sounds like collaboration and partnership is very important. Seems to be a theme. So as we close this discussion, let's look ahead. Both technology and research are evolving rapidly, so it's essential to understand what's coming next and to understand how our faculty can prepare for the future. This question is addressed to all three of you, so I'm going to ask all three of you to respond. In your view, what emerging innovations will shape the future of education and research in the next 3 to 5 years? And what challenges might institutions or educators face in adopting or implementing them? John,
I'd say at the moment it's quite a relatively recent development within AI itself. But AI is kind of breathtaking to try and keep up with, even if you're developing with it. There's one really interesting development that's come up in the last few months, which will hopefully allow us to create smaller, more specialized models. It's a technique that's been around in AI and machine learning for years, which is called reinforcement learning. But there's a particular way that's being applied to large language models at the moment, which means the performance of a smaller model can be increased in a specific field by a huge amount. And so instead of having one huge generalized model where you're reliant on a big American company to provide your compute power, it now looks like we're going to move towards more specialized models that can be run in-house or on your own infrastructure, and specialized to the culture, to the language, and hopefully potentially to a university or even to a faculty at some point. So I think that's the most interesting development coming through with AI and LLMs at the moment.
Great, thank you. And who would like to go next? Dr. Natasa?
Thank you. Yeah, so as it happens, QCRI has worked in AI, and we have developed the contributed to the national strategy for AI, and then we developed a large language model for Qatar called Fanar. You may have heard of it. It was released in December. So we are very, very careful. In a sense, we have developed something that is culturally appropriate, and which means that we control what goes into the model. And that's the big difference between, say, using somebody else's model and the one that you know what's inside. When it comes to the future, the key issue is really a responsible way of delivering this technology into the market. And where I stand, I say we don't experiment with kids. Just like we do not experiment with in medical sciences, we don't experiment with patients, we don't experiment with kids. I personally have been working a lot in quality assurance and quality control as part of my business and working with life sciences. So I know what it means when you're part of the regulated industry. IT is not regulated. It's not regulated. And that's important to keep in mind. So you can have Facebook and lots of kids may get bullied, or you can have a game where kids get addicted. Well, who is responsible? So I just want to say, looking forward, there are lots of opportunities, but I would encourage really critical thinking, assessment, and let's not experiment with kids. Thanks.
Great. Thank you, Dr. Natasa. And Dr. Vincent?
Yes, sorry. Let me start with the challenges. So I'm not entirely optimistic about global education in the next 3 to 5 years. Sorry for that. I mean, conflicts, forced displacements, climate disasters, I think they seems to intensify. So, I mean, it may lead to disruption in the schooling system worldwide, in many regions, I would say, and leading to bigger digital divide. And I think that even more new technology, new AI models will use more electricity, more internet bandwidth, etc. So I think that we assume that humanity is on a constant path to a better future, and it might not be always the case. And I sincerely hope it does. But the challenges we face, with the challenges that we face, I have some doubts. At the same time, I'm pretty optimistic about the fact that educational technology can really help making making education more resilient. So that's a good point, and especially for marginalized communities, displaced people, etc. And we already see some new resilient tools like offline AI models running on really simple, low-powered devices, etc., bringing digital learning in refugee camp, remote areas, etc. So while the global, the global outlook is a bit concerning, I'm still convinced that technology can really help making education more resilient.
Okay. Thank you, Dr. Vincent. You had us worried there for a bit, I'm sure. I'm glad you finished on something optimistic. Excellent. Thank you. The next question, again, is addressed to all three of you. What practical steps can educators take now to stay ahead of the curve and contribute to innovation in their classrooms or research areas?
I would say around AI again, my strongest advice would be you often see across all sectors, this goes from developers through business, through marketing and into education, you see similar attitudes. There's often a kind of adversarial stance that picks up as AI starts to come into an organization. It's me or the AI. Is the AI going to do this or am I going to do this? And then that brings up further problems about expectations of AI, expecting it to be perfect, and we know it's not. And many problems, I think, evolve around that stance towards AI. The most success you see with individuals and with organizations where they start to work with AI is where it's used as a superpower, basically. So where individuals begin to understand that it's not me or the AI, it's me plus the AI. How can I leverage the AI to do more? And when you kind of start to think about it as a potential superpower, that if you investigate with an open mind and experiment with, understand the limitations, understand what the AI can do and what you need to do in partnership with the AI, then the real power starts to evolve. But it's never just the AI. The most benefit always comes where an individual is leveraging AI to do more than they could before. So to get that mindset, I think, is the path to success.
Good. Thank you, John. Definitely.
Yeah, I'd like to agree with John, especially about keep open mind. It's very important to, I mean, we are educators and researchers, so we do that anytime. We always look for new stuff, we're always curious about things. It's part of the DNA of educators. The technology is moving very fast. Digital technology is moving very fast, and as I said, the sector is not regulated. That's why there is much more responsibility than on the experts who are using technology to judge it. And if something is not right, you should not pass it. Just because there's now a trend or your push, there's a strategy, you have to speak up. If something is not working, you have to speak up. It's not for yourself, you're speaking for kids. You're speaking because this is the education sector. Similarly, if you're in engineering, if you're building a bridge and something is not right, you will not let the bridge be built, right? So I just want to say, it's always about the critical thinking, it's about assessment, and the human is the source of knowledge, and the human is responsible for the deployment. And whatever people tell you, none of the technologies will take responsibility, believe me. If you read any package, any software package, look at the warranty, look at the library, zero. They're not going to take any responsibility. It's going to be all the responsibility in the people who are deploying. So I would just say, as advice, and this is I'm practicing myself, keep an open mind, eyes and ears, keeping informed, and then make expert decision, because nobody can replace you as a professional, and everybody will hold you responsible, because eventually it is about professional ethics that we all need to abide.
Thank you, Dr. Natasa. And Dr. Vincent.
Yes. And I invented the Beekee box when I was doing my PhD in educational technology at the University of Geneva, and I have a background in biology, and the idea was to create pedagogical activity for practical work in biology for secondary schools, and the idea was to make them more collaborative. And I created an activity where students had to take pictures of what they were observing with their microscope, was like insects, and share these pictures on photo sharing, simple photo sharing platform I developed, like you want a sort of Facebook platform for teachers. And when I wanted to test this activity in real settings, in real classrooms, the school said to me that there were no Wi-Fi for the students available in the schools in Geneva, and it was not like a technical problem, it was more like a political problem. So I had to find a solution, because the photo sharing platform was using internet, was an online platform. So that's where I started to configure like a small computer and install my platform to make it work offline in the schools. So to answer your questions, I would say embrace like an agile approach, meaning that you need to first identify a concrete challenge. Could be like increase student engagement, enable collaboration, etc. And then it's easier to pick up the right tool. And please don't start, like you said just before, please don't try to implement technology for its own sake, because technology is really a mean. And also start by doing a small pilot, small scale, consider short pilot in one course module on something very, very simple, and then gather feedback, data, refine the approach, then also leverage in-house expertise. I'm sure you have like IT teams, instructional designers team, maybe EdTech champions that can help you to implement a project. Also partner with solution providers, of course. And I would say iterate and scale up. So it's like an agile approach, really iteration after pilots, make adjustments, and then globally expand.
Great. Thank you, Dr. Vincent. Thank you to all three of you. That was the last question in that section, and I'd just like to say thank you to the panelists for those valuable insights. We now have 10 minutes for audience questions. You can feel free to go to one of the freestanding microphones or raise your hand and somebody will bring a microphone to you. We'll also be getting some questions that have been posted online for those of you who used the QR code.
Members of the panel, many thanks for your insight into this very important topic. Yesterday I was reading a research paper that says secondary graduates are not ready for university, while university graduates are not ready for the job market. Is this characteristic of lack of innovation in education, or is it something to do with the society as a whole? And what can technology do to bridge the skills gap? Thank you very much.
Okay, so there's two parts to that question. Does anybody have anything they'd like to offer in response to that? No?
Yeah, perhaps I can comment a little bit on this. So readiness to go from one level of education to another, and then the second comment was about finishing school and not being able to do anything in the job. The second one is easier to comment because actually in education we're not trying just to make people suitable for a particular job. We are trying to take a holistic approach and create individuals who can learn along the way. So if anything, perhaps the most important thing is to make learners learn for the rest of their lives. And technology may help with, as you already discussed, can help with self-motivated learning. So it could make the technology knowledge more accessible if it is in digital form. So we heard that. So I'll just say, if somebody cannot fit the job right away, I won't be that worried as long as they can be trained and they can be specialized particularly in this sector. But for the other one, I can't help. I mean, whether some high schools are more preparing students for university than others, I really don't have much insight there.
Thank you, Dr. Natasa. Okay, we have a question here.
First of all, thank you very much for this insightful discussion. In fact, Dr. Natasa, you mentioned the benefits of involving master students in research, in this collaboration between research and research academic institutions and industry. However, what do you think about involving the early stage undergraduate students into research, like first, second year students, because it may be very benefits for them in terms of critical thinking, practical skills development. However, it may be challenging also because they are at early stage, there is not enough maybe to go to research, but I would like to hear your opinions, maybe all of you, if you have any successful story or any comments or any directions to involve, let's say, undergraduate students into research. Thank you.
Yeah, I would just say I would endorse it fully. In fact, what I noticed, say, in UK it was much harder to kind of arrange undergrads to work with industry, but where I come from in Montenegro and from Yugoslavia, I actually know that in Slovenia they start from high school. They basically get the kids from high school and they connect them with the professors, especially like math Olympiads or very gifted kids. So there's in these other countries, smaller countries often, where you have a more agile kind of environment and people know each other, it may be easier. And I think for Qatar probably would be really great opportunity. I wouldn't say that there is kind of magic happening at the master level. What we do at QCRI, we do have internships with the undergraduate students, and when we get somebody who graduates, get them as a research assistant and a research associate with master. So there is a progression even within the institute, but definitely collaboration with the industry. If there is time in the curriculum, if the professor can make arrangements, yeah, why not?
Two more questions up in the audience.
Hi, Dr. Daat Farid, Healthcare Management Program Coordinator. This was a very nice panel. Thank you so much for the panelists. I was moved by the words of we have to teach our students to speak up, and and the AI would not speak up for us, basically. We're in an age where basically AI is taking over. I know for a fact in hospitals now facial recognition is something that's normal to do, almost normal to do without the consent of the patient in order to update the scheduling and the booking of the patient. Where, for example, in airports where they're going to take facial recognition to see your impressions of emotions and if you're happy or not, and they would look into that. So cybersecurity and the consent of the user seems to be a very important topic in education right now. So thank you so much.
I would just like to make one comment. When people say AI is taking over, please, AI is not responsible. It is the humans who are responsible for deployment. So if you go to a hospital and somebody does the facial recognition on you, it's not AI. It is the director of the hospital who decides. So please, let's not move the responsibility to technology. It is about still us.
I'd just like to add something to that. In that we all have responsibility to make the most of AI as it comes across us, basically. We can either kind of ignore it and reject it, but it will still come into place, and others will control how it happens. I think it's very important for organisations such as UDST to stand up and have a voice and have a clear direction in how we use AI in education. Because if you don't stand up and don't take a position and a direction, then somebody else will. So it's key to approach it that way.
Great, thank you. There was one more question from... Okay. This microphone.
Thank you. Thank you very much for this interesting discussion. I'm Bickee. I'm Associate Professor, Healthcare Management. When I do research, and I do quite a few of them, always what drives me is a question. What is it? There's a knowledge gap. But I've never thought about commercialization. But today, listening to you, in my head, how could I commercialize some of the things that I have done? Or anything in the future that I'm going to do, how I could commercialize. So maybe you could tell us how, when I identify a particular area that I'm interested in doing research, how would I think about the commercial opportunity for commercialization? Because I've never thought about commercializing a particular product. And recently, actually, the past year and a half, I was working on a particular subject, a concept analysis on value-based healthcare. So recently, it was accepted for publication, so I'm very thrilled about it. But I never thought about it, so now I'm listening to you. I said, could I have thought about this in terms of an end product, of a commercialized product that could be of benefit in the healthcare system, in the healthcare sector? Of course, there will also benefit for the university, because if it's well used, then the university's reputation and maybe some revenue for the university as well. So maybe you could give me some advice as to how when we identify a research area, we could also start thinking about commercialization. Thank you.
Very, very pleased with the question. So there is something we call the life cycle in innovation, right? We start with an idea, and some people are using these technology readiness levels that the NASA put in place. So if you go online and look at the Wikipedia, it will spit out for you the technology readiness levels from 1 to 9. And so normally you start with the concept, so it is like concept map, and that can be used I may have an algorithm. If I want to convince you that this is a good algorithm, I'm immediately thinking about some kind of use case. It's a hypothetical use case. And at that point, I'm really thinking about many different areas. But none of that is validated yet. It is for me to explain why my algorithm is good and potentially what may be useful. So in the research, we normally do what we call technology readiness up to 4. You go to the concept, you do implementation, and then you create a demo. And the demo is running on my laptop. Yeah? So then the next step is, I have to give this laptop, I have to install it on somebody else's laptop. Well, it better works then, because what I have just done, I have created a whole environment in which things may work. But the next level, what we call technology readiness level 5, is when the demonstrator system can be put in other places and possibly evaluated. And that's where everything breaks. Because at that level, it's not enough for me to have a master's student or PhD student or help from a friend to do it. Now I need a proper engineer. So now it becomes interdisciplinary work, meaning 2 different specialists are working together. It may be still your friend, may not be formally consultant that is doing the software, but somebody needs to do the technical part, which is not part of research anymore. So we go levels 5, 6, 7, and then we hit another barrier. We've got something that's working, it has been tested, we have a pilot, and then we need to figure out the business model. meaning which market we need to go to, and we decide which market we go to, guess what, then there's more research done there because it's never ready for a particular instance. One has to go very, very deep in order to create value. So what I would just say, for university, it has to be very clear what the research is going to have, what impact it will have. The easiest thing is to have licensing. So you have created something, and then you say, well, let other people take care of the rest. Let them get engineers, let them get the commercialization force, sales force, and then to take care of it. So licensing is the easiest, which means you may do the patenting and then the licensing deal. But if somebody's asking you, well, did you make any money? You have a little money from licensing, often. Because the first thing that the company will do, try to get rid of you, they will look at your license, do something, and then they will do something else, maybe even re-implement things with the modern technology, and then you lose the IP. So I just want to say, one has to have make a very hard decision how far to go. Universities are normally happy with patents and licensing deals. For us, for institute, we go further with productization if we can, and then find partners who can then deliver or services that can deliver. We still have a problem with sales, because this is a completely different type of people. You cannot have professional paths for them within the organization. So HBKU has the HBKU R&D Corp. We put an external organization that actually deals with customers. Through them, we can actually have sales people.
Thank you, Dr. Natasa. I think we do have a few minutes, about 5 minutes remaining, and I have one question here that was submitted through QR code that I want to ask, and feel free to jump in on this. This one is AI related. I'll just read the question as it's written. Exciting and challenging time that's shaking the conventional educational agency, where trainers are at a disadvantage versus trainees who are shown to be knowledgeable. What roles can the university play in the futuristic AI empowerment if students are leaping ahead of their teachers? I just thought it was an interesting question. I don't know if anybody has a response.
It's tricky, no? Like, you see it's not just common to the education sector, you see it everywhere. We see it in development. I talked to a big group of fellow developers in London a month ago, and it's chaotic. You get some junior who's pumping out extraordinary amounts of features in the code and overloading all the infrastructure above them. So I don't think it's something to feel like there's a particular problem in education. It's just the nature of this sudden and huge shake-up coming through all sectors. And the only advice is to get on it. Basically, you need to learn it. You need to learn from your students. I mean, if there's a student that's excelling and doing something you don't understand, ask the student. This is the only way. You have to learn and catch up. There's no other choice.
So embrace it. Very good. Okay. Anybody else?
Maybe just a quick comment on my side. The thing is that the reason why the student looks advanced is because they got technology, they got the fact or some kind of knowledge before you had the chance to look at it. It's not because they're smarter. It's just that people have more access to information. And by the way, I would not recommend AI, generative AI, to be your source of information. It is what we used to do before AI. You go on Google and then you go to your doctor and you start diagnosing yourself and telling the doctor what you've got. And still, so yes, I'm becoming more knowledgeable because I got some facts. And this thing about access to information earlier than somebody else, actually we see this in education too. When do we think that the student is smarter? We think the student is smarter because they're ahead of the class. Well, how are they ahead of the class? Well, they have somehow they got knowledge ahead of everybody else. And you know, just in my life, I know that there are parents who are paying for tutors for kids to become smarter ahead of their peers. But it doesn't mean that they're smarter, they just have the facts, they have knowledge. What you judge people is on how they use it, how they apply it. So I'm not I would not be worried as a professor. I would not be worried if somebody can get information before me, because education has to move to the next level. How do I reason about it? What's my critical thinking, and how do I apply?
Can I say something? Actually, I have. Thank you very much. This is a very tricky question, but I have a suggestion. I mean, it's, we can use an AI to create, let's say, a teacher-assisted body, which he can present at the same time in the classroom, and he can be shadowing the teacher. And if a student uses some of the technology, the AI can assist the teacher answering the student.
Interesting point. Okay, thank you, Dr. Salo. All right, so that's the end of our panel discussion. I would, on behalf of my colleagues here at UDST, I would thank John, Dr. Natasha, and Dr. Vincent, and thank you for attending.
I would like to extend a heartfelt thank you to our distinguished panelists and outstanding moderator for their thought-provoking insights and enriching discussion.